All right, thanks for joining me. We're going to go through some of these on your handout. You can make sure that you got the right answers and understand why. So this one we're doing polyatomics, but in some cases, again, we may have some Roman numerals, we may not. So as we go through these, that's one of the things that you're having to do as you go through this is try to figure out what do we have here. So in this case, on number one, we've got three elements. So there's a good chance one of them is going to be polyatomic. And again, you have to sometimes just go through your chart to figure out which one is the polyatomic. Usually they're going to be the negative one, which means that your positive charge is usually just going to be a metal that's on the periodic table. Go into SO3 is its own thing, and I've got some here. So this would be potassium sulfite, and then we're done. Again, we don't need to put Roman numerals because we only use Roman numerals if it's a transition metal. So as I'm going through this, I'm kind of identifying, is it a metal? Is it a transition metal? Is it a non-metal? Is it polyatomic? Kind of making some decisions so I can figure out best how to name. So again, same thing with number two. If I go through and look at this, I've got multiple things here. So there's at least one polyatomic, but there's only three elements here. So it's impossible for them to have two polyatomics with three elements because polyatomic, you'd have to have 2 and 2, there have to be at least 4 things here. So I've got sodium, chlorine, and oxygen. Again, if you go and look around on your periodic table, you won't find NaCl on the polyatomic, but you would find ClO3, right? And so then again, we'll say our next step is this a transition metal or not? And sodium isn't. So if we were naming it, it would just be sodium. ClO3 is, according to your chart, is chlorate, and that's it. All right, now number 3 is a little bit easier because the parentheses do show up, so we know that that's a polyatomic ion, which means we also probably know that one's a polyatomic ion. And a rule is just write the ions down. So in this case, we've got ammonium. You've probably heard of ammonia, which is similar. Again, phosphate, the second part. We're done there. Number 4, same thing. We've got the parentheses, which helps us out a little bit. Shows us kind of which one is the polyatomic. Remember up here, we don't have parentheses because there's only one of them. So this SO3, there's just one clump of SO3. There's not, in this case, there's like 2 of them. So I've got this NO2 group, but then there's 2 of them, which is why we set it off in parentheses. So I asked myself, is this a regular metal? Is it a transition metal? Magnesium's in group 2. So it's not a transition metal. So I just write magnesium. I don't have to worry about Roman numerals. And then NO2 is nitrate. Got that from my chart. We're done. All right, I've got an NO3, so that tells me that's my polyatomic. But in this case, I've got iron. Got to make a little move here with iron because iron is a transition metal. So I have to use parentheses with it. All right, so then the problem is I have to figure out which version of iron do we have. And so NO3 is nitrate, and I don't really have to think much about it. So again, how do we figure out what goes in here? Well, just remember the number that goes in here is the oxidation number. So if I can figure out what goes up here with iron, then I can figure out my Roman numerals. So let's reverse crisscross. If I take the 2 and move it over here to iron, there's an invisible 1 here that I would move over to this. So what I need to do is double check, is nitrate's charge -1? I'd have to go look on the chart again. Nitrate's charge is -1, which means then that iron's charge would have to be +2. So this is the same thing we did when we were just basically naming simple formulas with transition metals. We have to like reverse crisscross to figure out what our charges would be for our transition metal. And we have to write that in. We'll scroll down just a moment. All right, number 6, same thing, lead is a transition metal, which means it's going to need parentheses. SO3 is the rest of it. Again, that's sulfite. I'm just checking my notes because I don't have my ites and eighths and everything memorized. So how do I figure out, again, what goes in here? I need the oxidation number. All right, so to get the oxidation number, I got to do a little bit of reverse crisscrossing. Now, again, here's where you got to be careful that this SO3 is not what we would end up reverse crisscrossing because that 3 is a part of the sulfite. So remember, effectively what we've got going on here, parentheses around this with a 1. And since we have a 1, we got rid of the 1 and we got rid of the parentheses. So if we crisscross backwards, then we end up getting -1 and +1 in both ways. So this 1 ends up with the iron. Iron's 1 ends up over here. Now in this case, this is not the charge for sulfite, because I already looked this up, I have the chart in front of me. Sulfite's charge is actually -2. So if sulfite's charge is not 1 but 2, then lead's charge is not 1 but 2, because we have to keep these balanced out. Our ratio down here is 1 to 1. So this would end up 2 sulfite to get our answer back in the right place. All right. If we're doing formulas, again, we do formulas just like we have been. We need to figure out oxidation number. Copper is +2. Sulfate is -2. If I crisscross, right, I get a 2 and a 2, which we would reduce to 1 and 1, which we would just not write at all. So then my formula is copper. And then sulfate is in SO4. Again, I don't put parentheses around the SO4 because we only have one of them. And that one's done. Beryllium nitrate, beryllium, regular metal, right? Hang on just a second. Right, so beryllium again is in group, so it's a +2 charge. Nitrate's a -1. So we get those, we crisscross, which means the 1's going to end up over here with beryllium, the 2's going to end up over here with nitrate. And so our formula is I'm going to have 1 beryllium, nitrate NO3, and since I've got 2 of them, I'm going to write those in parentheses. So that's beryllium nitrate. All right, sodium carbonate. Again, sodium's +1. We get that from our periodic table like we have been. Carbonate, you have to use chart, which is -2. With crisscross, that means the 2 is going to end up over here with the sodium. The 1's going to end up over here with the carbonate. So my formula would be Na. And then carbonate is C. Because I've only got them in parentheses, I just leave it this way. Let's scroll down. Right, zinc sulfate. Zinc is a transition metal, so it already gives us the oxidation number for zinc. Sulfate again is -2. So if we ever get to the point with know with this +2 and -2, that eventually we're gonna, if we crisscross, we get 2 and 2, which is going to reduce to 1 and 1, and then we don't even write the 1's. So the formula for zinc sulfate is just Zn. It's a really bad Zn. And then SO4. I don't put a parentheses around it because I've only got one of them, and we're done. All right. Gold is Au. In this case, it's +3. Sulfate's -2. If I crisscross, then the 2 is going to come over here with the gold, and 3 is going to end up over here with the sulfate. So this is what I'm going to use in my formula because I can't reduce those. So gold Au2, and then sulfate SO4. And because I've got 3 of them, I'm super confused. So again, this 3 is telling me I've got 3 of everything in the parentheses that's here. And then finally, potassium permanganate. Potassium is on our periodic table. Group 1, permanganate, which I have to use our chart for, which is a -1, which means they're going to perfectly cancel out. So potassium symbol is a K. Permanganate, if you looked it up, is MnO4. And again, because there's only one of them, we don't use parentheses. We just leave it the way that it is, and we're done with it. Okay. All right, that wasn't challenging enough. We got these where they're all mixed up. And so one of the first things we need to do is evaluate what's going on. Do we just have regular ions? Do we have transition metals? Do we have polyatomic ions? And that helps us to figure out the name and the form. So if I come in this one, lithium and P, this is where we started from. So lithium's in group 1, phosphorus is a non-metal. So if I'm writing the name of this, it's just our basics. Lithium. And remember, we would change the phosphorus to an IDE ending. So remember, we use IDE if it's just the element that's on there. So this will be lithium phosphide. Okay. We go to 14, potassium phosphate. So potassium is an element, it's not a transition metal. And phosphate is one of our polyatomic ions. So if I write things down, I got a K. And then phosphate is PO4. And then I need to figure out, do I need any numbers down here? Do I need subscripts? So again, I got to do some crisscrossing. So potassium is +1. If you look on your chart, phosphate is -3. So if I crisscross, the 3 ends up over here with potassium, the 1 ends up over here with phosphate. So if I take those into account, the 3 is going to go here. The 1 would go after the PO4. Like, remember, this whole thing is just acting like one thing. But if I have a 1, then I don't write the 1 and I don't write parentheses, and I should be finished at that point. A little bit more thinking going on with having to do them like this. All right, 15, PO3. Again, usually if there's more than 2 elements here, we're going to have something polyatomic. Usually the polyatomic is going to be the negative part. So you can look on the ending down here to see if you can figure it out. So PO3 is something that we would find on the periodic table. So if we write this is going to be sodium. And since sodium is not a transition metal, I don't need parentheses. And then PO3 is phosphate. And that's all we have to do with it because we're just naming. Okay. Naming should be pretty simple. The only thing is if it's a transition metal, we need to put the Roman numerals in there, just like we have here with 16. 16 is iron 2 borate. So iron is Fe. And if you go to the periodic table, or excuse me, the back of your new periodic table to find borate's ion, which is BO3. Now iron's charge, again, I got to figure out now what do I put any subscripts here to balance these out when I write the formula. Iron is +2, borate is -3. Again, you'd get that from your chart. Where did I get the 2 from? Well, again, that tells me that it's 2. Crisscross. So the 2 ends up over here with borate. The 3 ends up over here with iron. I can't reduce those, and so those are the numbers I'm going to use in my formula. So the 3 is going to go here with the iron, and the 2 is going to go over here with the borate, but I need to make it not look so confusing. Put some parentheses around it, and we should be done there. 17 is copper, and then we've got the NO3, which is nitrate. Again, naming is usually the easier of the two things, but in this case, I've got copper, which is a transition metal, so I need to know which Roman numeral to put in here. So let's reverse crisscross. There's an invisible 1 there, so that would give me a 1 and a 2 if I reverse crisscross. Now again, I got to double check. Is that actually nitrate's number? If you go look on the polyatomic chart, you would see that nitrate is a -1, which means that copper in the case would have to be +2 to balance things out. And this would be copper 2 nitrate. Okay. Sodium silicate formula. Sodium off the periodic table. Silicate, would have to look it up because it's not on the periodic table. It's polyatomic. And again, at this point, you might say, well, I'm done. Well, you're not done. We've got to make sure that I've got subscripts in here to balance everything out. My charges, sodium is +1. Again, first column of the periodic table. Silicate, if you look it up, is actually -4. So if we crisscross, there should be a 4 ending up with the sodium and a 1 ending up with the silicate. So I'm going to take this 4, stick it in here, and then we have this 1 would be for the whole SiO4. There's a 1 of those, and I can't really, I'll just erase that, try to do the undo, that didn't work. So I need to leave it just like that because I've only got 1 of them. All right, 19, calcium oxide. Again, got a Ca for calcium, and that's off the periodic table. That's the IDE version of numbers here at the bottom. Calcium is +2, oxygen is -2, just like they always have been. Crisscross, I get 2 and a 2. Simplify a 1 and 1. Don't write ones. We're done there. That's what calcium oxide should be, nice and simple. So sometimes they're still going to be simple. And then finally, that's AgSO3. SO3 is our polyatomic. If you look on your chart, Ag is silver. Silver is a transition metal, which means I need parentheses. SO3 is sulfite, which is all that I need to do with it. But I need to figure out what to put in the parentheses, which means I need to figure out what is silver's oxidation number. If I reverse crisscross, the 2 is going to, let me clear some of this up. It's getting a little messy. The 2 is going to end up here. The 3 is going to end up there if we reverse crisscross. double check on your chart to see is that sulfide's charged, which it is. If that sulfide's charged, then that is silver's charge. And then this is the number that's going to go into the parentheses. 1, 2, 3, silver 3, sulfide. We're in good shape. Real quick, last one on here, group 1 metals, if they lose an electron, if we formed them in a 1-to-1 ratio, then they would form a 1-to-1 ratio with something that's going to gain 1 electron. Group 17's oxidation number is +1. These other ones are not +1, which means you're not going to have a 1-to-1 ratio. C would be our correct answer, such as NaCl. NaCl is in a 1-to-1 ratio. You have 1 sodium for 1 chlorine. All right. Thanks for joining me. Hope that helped.